Hello everyone, my name is Peggy, and today I'll be talking about life tables, premium reserves, premium payments, mortality profit and loss under the context of life contingencies in this video. So for question 1, we're required to choose one country to work on, which the country I've chosen is Taiwan, and we are required to collect the data from the HMD website for year 2020. So there are three requirements in this question. The first one is to create a life table that imitates the illustrative life table, and the second one to construct a life table including the commutations dx, nx, sx, cx, mx, and rx, and the third one to construct a life table of increasing annuities and also EX. All these life tables are constructed and calculated with 5% and 6% interest rates respectively. So for the first requirement, illustrative life table, these are the formulas that will be used because under this life table we have QX, double dot AX, capital AX, 2AX, and NEX as our components. So going to our Excel sheet, this is the information imported from the website, which is the data of Taiwan in year 2020. So the base information we will use is LX for this question. So putting in here, firstly we will calculate QX. So the formula for QX is LX minus LX plus 1 divided by LX. So we will use LX minus LX plus 1 divided by LX and input it into the Excel function times 1000 to get 1000 QX, and we drag it all the way down. So for A double dot X, the formula is 1 minus capital AX divided by D. So we don't have this yet, so we will go on to capital AX first. So for capital AX, we will use this formula, which is V times QX plus V times PX times AX plus 1. So V, we have calculated V, which is 1 over 1 plus I. So inputting the formula into the Excel function, we can obtain the values and then drag all the way down to get all the values for all x. So after getting ax, we can construct double dot ax, which is 1 minus ax, remember to divide it by 1000, and then divide by d, which is I times v. So we can also drag it all the way down to get all the values. So 2ax, the calculation is similar to ax, but we calculate this using v power of 2. So we can get all the values and drag it all the way down. So for nex, the formula will be v power of n times px plus n. So in this case, our nex is 5ex, so we will have v power of 5 and px plus n equals to lx plus n over lx. So when x equals to 0 and n equals to 5, we will have L5 divided by 0 for this. So we can also drag it all the way down to obtain all the values. And for 10ex and 20ex, the calculation is similar to 5ex, just that we have to change the value of n to 10. Yeah. So with this, we have completed the first requirement, which is to calculate the illustrative life table. And for I equal to 6%. We have the similar method to calculate all the values, just that we have to change the I, which changes the values of V and D consequently. So for the second requirement, we have to create this life table commutations table. So these are the formulas for the commutations, and we can input it into Excel respectively, and we can get all the values. Note that Cx we have to use dx, which is the value equals to Lx minus Lx plus 1. So others, we just input all the equations and then we drag it all the way down to get all the values. Similar for table using I equals to 6%. So for the third requirement, we are required to include increasing annuities and also EX. So these are the formulas, which is for I capital AX, the formula is VQX plus VPX times IAX plus 1 plus AX plus 1. So we just input it into here, and then we can get the values, and then we drag all the way down. So for I double dot AX, the formula is SX divided by DX, which we can obtain from the table above that we calculated just now. For EX, the formula will be PX times 1 plus EX plus 1, and we put it into the Excel function, which is PX equals to LX plus 1 divided by LX, and then times EX 1 plus EX plus 1, which is this. And then similarly, we drag it all the way down to obtain all the values, and as well as when I is equals to 0.06. So with this, we've completed question 1 by fulfilling all the requirements with all these tables. So now we move on to question 3. Question 3 states that as real life insurance issued a number of 20-year endowment policies to a group of individuals aged 45 on January 1st, 2005. In each case, the sum assured was 200,000 and premiums were payable annually in advance. Mortality is based on the constructed life table, which is the Taiwan life table I've constructed just now, and just that we have to change the interest rate to 4%. So the first requirement asks us to calculate the net premium reserve throughout the years 2016 to 2022. And the second requirement, we will have to calculate the mortality profit or loss in years 2021 and 2022 using these informations provided by the question. So firstly, to calculate net premium reserve, we have to use these formulas. So let's go to our Excel. In question 3, to calculate net premium reserves, we will have to obtain this value AXN, which is we have to obtain these values first, which is NEX and also the term life insurance APV. So to get NEX, we have to calculate it by V power of n times NPX as stated in the first requirement. So in this formula, we can see that NPX equals to PX times PX plus 1 until PX plus n. So for 20p45, we will have to product like times all of these throughout the years for age 45 to age 65. So for 19p46, we can just use this total and divide it by p45, and we can obtain this. And drag it all the way down, we can get all the values respectively. So for any x, we just use v, which is calculated here, with I equals to 0.04, and then power it by n, and then times npx. So to get the term life insurance, we will have to use AX, which A45, the X respectively, and then minus NEX divided by A65. Sorry, times A65. So drag it all the way down to get all the values, and we can obtain AXN by summing up these two values. So after we have this, we can calculate the APV of benefits by multiplying this value with 200,000, which is provided by the question. So the double dot AXN is 1 minus capital AXN and divided by D, where we have showed this formula when we calculated the illustrative life table in the first question. So the APV of premiums will be the APV of benefits divided by the double dot AXN and then times the APV of premiums will be the APV of benefits for X equals to 45, and which is in year 2005, and divided by A double dot AXN in year 2005, and then times with the respective double dot AXNs. So we drag it all the way down and we can get all the values. So finally, we can calculate HV, which the formula is APV of benefit minus the APV of premiums. So in this, we can just use the Excel function to subtract the APV of premiums from APV of benefits. So now we have completed the first requirement of the question, and the second requirement of the question we will have to calculate the mortality profit or loss. So to complete this question, these are the formulas we need to use. We have to calculate the death strain at risk, the expected death strain at risk, the actual death strain at risk, and also the net mortality profit of the net mortality profit or loss. So this, to calculate the profit or loss, we will have to use the expected death strain minus the actual death strain. So to calculate net amount at risk, we will have to use 200,000 minus the HV we calculated just now for X equals to 61 and 62 respectively. So for the expected net amount at risk, we have to multiply the net amount at risk with LX provided by the question, and also the QX in the life table, which is the expected death rate for that year. So we'll calculate this. for both x equals to 61, 62, and we have to move on to calculating actual net amount at risk. So for this value, we will use this dx over lx instead of the qx we used here, because this is the actual death rate for that year and we can get the actual net amount at risk. So we times the net amount at risk times with lx and dx over lx for both years. So to calculate profit or loss, we just subtract the actual net amount at risk from the expected net amount at risk. So we can get both the values and we can see that for both years we are at a loss because the value is negative. So we have completed question 1 and 3 altogether, and that's all for my presentation. Thank you for your time for listening.